Hi everyone, today we do Cambridge A-Level Further Mathematics. The syllabus code is 9231 and this is the paper 2 for Further PO2, variant 1 from May-June 2025 series. We go for question 5. This is a second order differential equation that is not homogeneous, and we are given some initial conditions, the boundary conditions here, and we want to find the particular solution. Okay, so let's firstly we have to deal with the homogeneous part, right? Where for the homogeneous part, we let the entire differential equation let it equal to 0. Then we assume a solution of or x or homogeneous solution of x that it takes the form of e to the kt, right? That means the first derivative will get k e kt, and then the second derivative we get the k square ekt, and we substitute this into the equation and we can do some factoring. So we know that the exponential function will never tend to 0, or it will go very close to 0 but it will never actually equal to 0, so that one yields us no solution, and the only solution will come from our auxiliary equation, which is this quadratic in terms of k. And the solution to this, you have to use the quadratic formula. Right, we know that if we have a imaginary or complex solution for our auxiliary equation that takes in the form of, right, k equals to lambda plus minus omega I. If the solution of the auxiliary equation is this one, we know that the homogeneous solution of x will be taking in the form. So now we just substitute our values of lambda and omega. Right, so now we have dealt with the homogeneous solution. Let's go for the particular or the non-homogeneous solution. Right, so for non-homogeneous, we have to look at whatever the function that is equal to. In this case, is e to the negative t. So we have to assume a particular solution of x in terms of something like c3, arbitrary constant, and the exponential function with some constant also inside. Let's say gamma. Okay, and we take the first derivative and also the second derivative, so that we can substitute this back into the differential equation, and we equate it to the function that has been given to us. So let's factorize out the exponential term first, so that we can make a direct comparison. We can notice that the coefficient of our exponential term here, there's 1. So this entire equation or expression in front of the exponential term, you can equate that to 1. So just note that first. But this equation has two unknowns, so we have to solve for gamma first using this information that we know that this exponential term, the coefficient of t, there is a -1. So directly from there we know that gamma must be -1, and substituting this into the other equation, we should be able to get the constant term there is 1/9. So our particular solution, we have found it to be 1/9 e to the power of -t. Then yeah, now we can solve for the general solution. So our general solution x of t, it will compose of the sum of the homogeneous and the non-homogeneous parts, which will be this long expression. We have this also some initial condition. when t is 0, x and dx dt will be 0. So let's say x0 is 0, and also dx dt evaluated when t is 0 is also 0. So let's deal with this x0 first. Substitute 0 into all of the t, all the exponential terms will just go to 1, right? So we can make some cancelling here. E power 0, that's 1, that's 1, and this sine 0 is 0, cosine 0 is 1. So we know straight away that C1 is negative 1 over 9. Right, now for the first derivative, we have to take, unfortunately, we have to take the derivative. So that will be slightly long. Okay, dx dt. And we can see here there is a what we call as a product between exponential and also the cosine and sine. So we have to use the product rule here. Okay, after that humongous differentiation, you should be able to get this expression, but fear not, we just have to substitute 0 everywhere and equate it to 0. So let's try and simplify this, okay, as fast as possible. All the exponential terms just goes to 1, 1, and 1. Sine 0 goes to 0, sine 0 goes to 0, cosine 0, that is 1, cosine 0, that is 1. So we're left with negative 1 over 4 C1, and 15 or square root 15 over 4 C2 equals to 1 over 9. We know that C1 is 1 over 9, so okay, C2 should be square root 15 over 45. Now we substitute back into the solution, okay, so this will be the final answer. Okay, the final answer. And yeah, that's how you solve a second order differential equation, non-homogeneous.